Okay, pre-calculus, we move on to section 7.3, and now we're going to solve trigonometric equations, okay? You learned inverse trig functions, so that if I were to put something like, hey, what's the inverse sine of square root of 2 over 2, I'm asking you, especially if well, we go from negative pi over 2 to pi over 2 for the limited domain for sine. So if I'm asking you from negative pi over 2 to pi over 2, where is the sine value, the y value, equal to the square root of 2 over 2? You've got to go find the spot where square root of 2 over 2 is as a y coordinate on the unit circle. And so that answer is pi over 4, right? That's an inverse sine thing. Well, now look what I'm going to do. I'm going to give you a trigonometric equation, and we're going to start solving these and find out the angles that you could put in there that would make this equation true. So a lot of the skills you need for this are algebra skills that you guys are actually really, really good at. And then the last trick will be applying an inverse trig function. Okay, so the first one, determine whether pi over 4 is a solution to this equation. Well, this I would just substitute in here. 2 times the sine of pi over 4 minus 1, and I'm wondering if that's actually true. Well, we just used that. The sine of pi over 4 is the square root of 2. So this is 2 times the square root of 2 over 2 minus 1. Is that equal to 0? Well, no, because the 2's cancel, and the square root of 2 minus 1 is definitely not equal to 0. So I'm going to say no, it is not. All right, then I'm going to move on to, let's just start solving some equations here. Ready? Solve the following equation. Now look, I'm going to do this from 0 to 2 pi. I want to know every angle around the circle once that makes this equation true. So let's get cosine of theta by itself. Divide by 2. So when I divide both sides by 2 using regular algebra techniques, I end up with the cosine of theta is equal to negative 1/2. So since the directions say 0 to 2 pi, I'm looking for everywhere that cosine is negative 1/2. Well, let's remember that every single point on the unit circle is cosine of theta is the x value and sine of theta is the y value. So I'm looking where x value is negative 1/2. That means nothing over here. Quadrants 1 and 4 are out. So here's a point where I have negative 1/2 as a x value, and here's a point way down here where I have negative 1/2 as an x value. Having trouble writing the square root of 3 for some reason today. So since it's not the limited domain situation, if it was, my answer would be this one up at 2 pi over 3. I want every angle from 0 to 2 pi, so I actually have two answers for this. Okay, one of them is 2 pi over 3. That's 1 pi over 3, 2 pi over 3. And then we go 3 pi over 3. This is 4 pi over 3. So I actually have two answers that I have to put for this example because there are two places on the unit circle where cosine is negative 1/2. Okay, now look what I got. From negative 2 pi to 2 pi. So if that's 0, I'm going to go all the way to negative 2 pi. I'm going to go around until I hit 0. I'm going to go around again until I hit 2 pi. So let's see what happens with this equation here. Okay, I'm going to write it over here so I got a little more room. 2 times the sine of theta plus the square root of 3 equals 0. Well, I'm going to subtract the square root of 3, so I get 2 times the sine of theta is equal to negative square root of 3, just by subtracting. Then I'm going to divide by 2, and when I divide by 2, I end up with the sine of theta is equal to negative square root of 3 over 2. The sine of theta is negative square root of 3 over 2. Now, where does that happen? It happens here. Again, we're at the same place, 4 pi over 3. And then there's another spot on the circle here at positive 1/2 and negative square root of 3 over 2. Okay, now let's see, how many angles am I going to get? If this is 0 and I go backwards to negative 2 pi, I've got two angles here. And if it's 0 and I go forward to positive 2 pi, I got two angles. So I'm actually going to have 4 different answers. Ready? We'll go in numerical order. So I'm going to go to the furthest negative. That is pi over 3, and that one is negative 2 pi over 3. So my first answer is negative 2 pi over 3. And then if I go back to this one, that's negative pi over 3. Okay, there's two answers. So I just went from negative 2 pi up to 0, and now I'm going to keep going. I got to get all the way back down to here. That's 4 pi over 3. And then I got one more. That's going to be 5 pi over 3. If the directions tell me, give me every angle from negative 2 pi to 2 pi, it's 4 different angles. They're both of them at the bottom of the circle. One for negative 2 pi to 0, and then one from 0 to 2 pi. All right, there's page 1. Let's see how the next page goes. I don't have a picture of the unit circle here, so you got to know things now. This is a little weird because I got a 2 theta in there, but I think you guys can handle it. Don't do this last. Like this will be the last thing you do right here. Okay, so get sine of theta by itself. So there's a 2 there, and it's being multiplied, so I'm going to divide by 2, and I'm going to go over here. I get the sine of 2 theta is equal to 1/2. Now I'm solving from 0 to 2 pi, right? So maybe it's not the worst idea to draw a circle just to kind of get a feel for these kind of things. So where is sine of theta equal 1/2? Well, sine is 1/2 here at square root of 3 over 2 and 1/2. And sine is 1/2 here at negative square root of 3 over 2 and then 1/2. All right, so it's in radians, so that's pi over 6 and it's 5 pi over 6. Those are my 2 spots, but look what happens here. So I have 2 theta equals pi over 6, and I also have 2 theta equals 5 pi over 6. So the last thing I'm going to do is I'm going to divide by 2. So it's almost like you pretend it's just theta for the majority of the problem. And then when you find the sine of theta equals 1/2, it's those 2 spots. But then the last thing I do is I divide by 2. So I'm going to divide this by 2 to get theta by itself. If you divide that by 2, it ends up being pi over 12. You guys should start being a little bit better at being able to do fraction stuff in your head here. And if I divide that by 2, I'm going to get theta equals 5 pi over 12. All right, there's your 2 answers to that. Now solve, here we go. Here we go. Look at what's going on in the directions. It's not 1 trip around the circle. It's not 2 trips around the circle. That means give me every one of the infinite amount of answers that we have. Okay, this is not going to be easy, you guys, so pay attention here. I'm going to solve this. I'm going to write it all the way over here. I'm going to give myself as much room as I can. 2 sine squared theta minus 1 equals 0. Okay, my first thing to do is to add 1 to both sides. So I get 2 sine squared theta equals 1. My next thing to do, I got to divide by 2. So when I divide by 2, I get sine squared theta equals 1/2. Now I have another thing to do. I don't have sine by itself. It's presently being squared. How do you undo something squared? Is you take the square root of both sides. But when you supply a square root sign in order to cancel out squared, you have to do a plus or minus. So my answer is that the sine of theta is equal to plus or minus the square root of 1/2. Okay, I know the square root of 1 is 1, so the sine of theta is equal to plus or minus 1 over the square root of 2. And I'm not allowed to leave answers like that. So I would multiply top and bottom by the square root of 2, and what happens here is I have the sine of theta is equal to plus or minus root 2 over 2. Plus or minus root 2 over 2. Now, the plus root 2 over 2, these are the y values, right? Up here, we've got square root of 2 over 2 for cosine, but we also have square root of 2 over 2 for sine. So it's good up here. Over here, we got negative square root of 2 over 2, and then positive square root of 2 over 2. That's a spot where the plus root 2 over 2 happens. Now down here, this is where the y value is negative square root of 2 over 2. That counts. And down here, this is another spot where it's negative square root of 2 over 2. So there's 4 places on this frickin' circle, and then I have to do this for all real numbers. Okay, this is how it goes. Theta equals pi over 4. There's a starting place. And then I'm going to say plus 2 pi k, where k is any integer. All right, what does that mean? That means pick any integer you want. 5? Fine, pick 5. So then go around the circle 5 times. Start at pi over 4, start right there, and then add going around the circle 5 times. 1, 2, 3, 4, 5. I don't know what that angle is. Actually, I could figure it out. 5 times 2 pi is 10 pi. It's 10 pi plus pi over 4, so it's like 41 pi over 4. That's that angle right there. I don't care what it is. All I want to know is if I pick any integer, this means go 1 time around the circle. So if you pick negative 2, go to pi over 4, go around the circle twice, negative, and you'll be at the same spot, and that will be another angle that has a sine of square root of 2 over 2. So I do that for every one of them. 3 pi over 4, the one in the middle of the second quadrant, plus 2 pi times k. And then I'm going to do another one 5 pi over 4. That's the one that's in the middle of the third quadrant, plus 2 pi times k. And then a fourth one is going to go 7 pi over 4, the one in the middle of the fourth quadrant, plus 2 pi k. This is my answer to this problem. Look at that. That's how I have to describe an infinite amount of answers. Okay, now if you notice one thing though, this one and this one are 180 degrees apart. That happens in both spots, right? So I could, I'm going to put a big or here, I could say pi over 4 plus pi k instead of 2 pi. That means go around the circle halfway as many times as you want. Go once, there's another place where it's true. Go twice, there's another place where it's true. Negative 4 times. 1, 2, 3, 4 half circles. I'm in another place where the sign is root 2 over 2. And then that takes care of quadrant 1 and 3. And now I got to take care of quadrant 2 and 4. So I would also say 3 pi over 4 plus pi times k. So there's a second way you could answer that. All right, this one will be a little easier because I don't have a squared anything, so I won't get the plus or minus. Solve for all real numbers. Okay, I'm going to write it over here again. 2 cosine theta equals negative square root of 3. The algebra is very simple here. I'm going to divide by 2, and I get cosine of theta is equal to negative square root of 3 over 2. Okay, you got to draw a unit circle and think about where on this unit circle do we have cosine, the x value being negative over here, square root of 3 over 2, that's here at the two 30-degree angle type things. Those are actually referred to as reference angles, 30 degrees above or 30 degrees below a 180. The reference is 30 degrees. You might hear that term from time to time. Okay, so this is where I have negative square root of 3 over 2, and then positive 1/2, and down here in the third quadrant is where I have negative square root of 3 over 2 and negative 1/2. Those two angles are 5 pi over 6 and 7 pi over 6. But again, read the directions, it's for all real numbers. So I can't do the plus pi k thing here because there's nothing that's true on the other side of the circle. This is where cosine has to be negative, so it's only these two. So I'm going to say 5 pi over 6, and I'm also going to say 7 pi over 6. But those are just two angles. That would be my answer if the question was 0 to 2 pi. But the question says for all real numbers, so I'm going to say plus 2 pi k and plus 2 pi k, where k can be any integer, and it will refer to as many trips as you want to go around the circle. As long as you start at 5 pi over 6 and start doing trips around the circle, you will land in the same spot. Okay, do one more, and then we'll go on to the next video here. Solve for the following equation from 0 to 2 pi. Now it's a tangent. Nobody likes tangents, like my cousin Gavin. So I got tangent of theta minus pi over 2. It's equal to negative 1. Well, again, just like we had with the sine of 2 theta, I'm going to ignore this for a minute. Just pretend that it just says theta. And I'm thinking, where is tangent equal to negative 1? So let me get this out of here. For tangent to be 1, tangent, remember, tangent is the y over the x. So for y over x to be some kind of 1, it means they have to have the exact same numbers. Doesn't that happen at these kind of things? The square root of 2 over 2, the 45-degree angle type things. Now, where would they be negative? It's positive, positive up here, and it's negative, negative down here. If I put that y over that x, that's going to be positive. Tangent is negative in these two quadrants, right? So from 0 to 2 pi, I'm looking for that angle and that angle. And so I'm going to get theta is equal to 3 pi over 4, and theta is also equal to 7 pi over 4. But whoa. It's not actually theta. It's theta minus pi over 2. So I have theta minus pi over 2 is equal to 3 pi over 4. And I also have theta minus pi over 2 is equal to 7 pi over 4. So the last thing I do is add pi over 2 here. So theta equals 3 pi over 4 plus pi over 2, and theta equals 7 pi over 4 plus pi over 2. Okay, if I'm adding, I got to have the same denominator, so isn't this like 2 pi over 4, right? Isn't that 2 pi over 4? So I get theta equals 5 pi over 4. That's one answer. And here, when I add 2 pi over 4, I actually get theta equaling 9 pi over 4. 9 pi over 4. That's a problem because that answer isn't from 0 to 2 pi, right? That's not from 0 to 2 pi. So what I got to do is instead of this 7 pi over 4, I actually have to think of this as being negative pi over 4. So that when I add pi over 2 to that angle, I'm going to get something that does actually fit. So watch, I got to go theta equals negative pi over 4 plus pi over 2. That's going to be negative pi over 4. Sorry, I got to write so small. I'm in the corner here. Negative pi over 4 plus 2 pi over 4, getting common denominators. And so I actually just get pi over 4. And if you think about where 9 pi over 4 is, you could have just found that angle. Like, look, 1 pi over 4, 2, 3, 4, 5, 6, 7. That's 8 pi over 4. So we went up to this one. That's where 9 pi over 4 is anyway. So you could have just looked at it and gone, oh, it's just pi over 4, instead of having to rethink and redo. See what I mean? So if you get an answer that doesn't make sense, find out where it is on the circle and put what it's supposed to be. You know what I mean? Let's go to the next video.